Let's take a look at a postfix calculator written in C# using a stack. Now it's a pretty straightforward algorithm, and I've kept it all in one method, not to demonstrate good design techniques, but just to keep the example simple. So we start by allocating the stack. Now this is the stack where we're going to store the intermediate integer values that haven't yet been operated on. Now recall from our algorithm, it starts with enumerating over all the tokens. Now in this case, the tokens are the input arguments. For example, if the input arguments were 5, 6, 7, star, plus 1 minus, what we're going to do is evaluate that expression just like we did in the slides earlier. Each of these values, 5, 6, 7, is one of the tokens. The very first token is the integer 5. So when we do a try parse, that succeeds. So we push that value onto the stack. And we'll continue that for the 6 and for the 7. But eventually we'll get to the star, or the multiplication operator. And the try parse will fail. That's going to drop us in to the operation evaluation portion of the loop. So what we're going to do once we're in here is start popping values off. The right-hand side is popped off first. The left-hand side is popped off second. Then we look at the operator and we switch over it. We find we had the multiplication operator. So we're going to evaluate left-hand side times right-hand side and push that result back to the stack. Now this is the same behavior for plus, minus, multiplication, division, and modulo. We perform the operation with the proper left and right hand side ordering, and we push the value back. Once the multiplication is done, we come back again, we do the addition, then we push 1 onto the stack and we perform the subtraction. Once the whole loop is done, we've gone over all of the tokens, we have one value pushed onto the stack, which will pop off and print as the answer. So let's take a look at this in action on the command line. I'm going to run the calculator, and I'm going to pass in like we've looked at. 5, 6, 7. Multiply, that'll multiply 6 times 7, the result of which will be added to 5. 1 will be pushed to the stack and subtracted from the result, giving us 46. Now we can see some simpler calculations. For example, 5, 2 plus, and that's 7. So that's a postfix calculator implemented using a stack. Now one thing to note here is that whether the stack was backed by an array or a linked list or some other structure didn't matter. It was the last in, first out behavior of the stack that made this possible.